So far in this course, you've learned a lot about how to program. You learned about data structures, you learned about writing procedures that accomplish things, including doing them in different ways, and you've begun to have the ability to write fairly complicated code. And you've also undoubtedly experienced that leads to bugs. And so we've talked a little bit about how to think about testing and debugging to get your code to do what you wanted it to do. And in that discussion, we talked about things like defensive programming, setting things up so that you plan ahead to try and prevent code, or at least prevent bugs rather, or at least have them arise in a way in which you can handle them well. And we've talked about the kinds of messages that the computer gives you when things don't go the way you expected. Today we're going to pick up on both of those topics to talk about the use of exceptions and the use of assertions, both to accomplish defensive programming and to let you actually control how the computer reacts when something goes in an unexpected way. So let's look at that. Exceptions really deal with that question of what happens when I'm running a procedure and something happens I didn't expect. I hit an unexpected condition. It's an exception to what we planned for, what we wanted to have happen. And what we've already seen is you will get an exception to what was expected, and that will lead typically to a message from Python. Some examples are you have a list and you try and access something beyond the length of that list. Little example right here. I have a list of length 3, I try and access the 4th point, and I get a little message saying I have an index error. It's telling me I've tried to go too far. I could have something where I try and convert an inappropriate type. I get a type error. I try and reference a variable, get the value for a variable, but I haven't defined it yet. I get a name error. I try and mix types together without actually forcing one or coercing one into being of the appropriate type, and I get a type error. These are all examples of an exception to what was expected, at least from Python's perspective. So what will we do with those things? Well, before we talk about that, let's think about some of the other kinds of common errors you've probably seen here. Syntax error. Python can't parse the program. It doesn't satisfy the rules of writing legal expressions. A name error. Either a local or global name has not been found by Python. An attribute error. When I introduce a class, which we're going to do shortly, or when I actually try and access an existing Python class, a reference fails. Type error, we've already talked about. A value error is one where I give an expression, an operand that is done legally in terms of the type, but the value doesn't make sense, and Python will complain. And finally, an input-output error, or an I/O error. Typically, I try and get a file, and it doesn't exist. So these are common types of errors. And again, part of our question is, what should we do when these things happen? We've seen some of the options already. So, what do we do when we run into an error? One option is just to fail silently. That is, substitute in a default value or just keep carrying on. Bad idea. Really bad idea. In fact, let me circle it because it's such a bad idea. The user gets no warning in this case that something has happened inappropriately. And while it's tempting to think about, well, let's just substitute in a default value for this and keep going, that could lead to all sorts of problems when you try and use that value later on. Second option is what we've already been doing. Return an error value. There we have questions like, well, what value should I choose to return? And if I'm going to return an explicit error value rather than printing out an error message, then I have to decide how do I have code that might get that error message, deal with it. I'm going to have to check for a special value. But it's still an option. And the third option is the one that we do right now, which is when we get an unexpected condition, we stop execution. And in Python, we say it raises an exception. It literally has a piece of code built into it with a special word raise that raises an exception with a string that describes what was going on when this happened. In fact, you've been seeing that when you've run code that doesn't run as you expected. Python is putting out an error message, raising an exception saying, I've got a type error and here's where you were when that happened. I know many of you have just ignored that and gone back into the code, but that error description actually is valuable. It tells you something about what was going on when an unexpected circumstance arose, and that helps you do the debugging. Okay, with that in mind, we can now think about doing things a little bit differently. And in particular, we can give you as a programmer, or Python in the built-in system, the opportunity to actually handle an exception when it happens. So here's a little piece of code, and I want to walk you through this to let you see what happens here. Try is a special keyword. And what it says is, with the indentation, here's a block of code. And what I'm going to ask the system to do is to try to execute that code. So it's just like I was having that code being handled inside of a Python shell. It's going to ask for some input. It's going to ask for some more input. It's going to then print out the ratio, and it's going to print out a message. But the difference here is the following. If try runs that block of code and everything works well, great. I jump down to here and simply print out what I had. On the other hand, if an exception is raised, the most likely one is that I'm trying to divide by 0. But I might also give in a string rather than number. If an exception is raised, particularly here in this print statement, then I'm going to jump to the except case. Again, a keyword that highlights a block of code. And in that case, I'm going to execute this information and jump outside of the loop. So say it one more time. Try says, try to execute each of these instructions in turn. But if an exception is raised, stop that processing, jump to the except clause, and execute those statements. And then carry on outside of the entire loop. This allows me to define things that I would like to do in the case that an exception arises. And right now it's simply printing out a message and stopping additional processing. But in a second we'll get to using this a little bit differently. So I'm going to now do a version of this code on my computer, and I've already pre-typed it in. So I've got an example of that little try loop, and actually I realize I've said something a little different here, so I'll change it to say OK in that place. And I'm going to add one more piece to this to make it consistent with what we had there, which is I'm going to put a print statement right here that says we're outside. And with that in mind, let's run it. So it says, give me a number. I give it 1. It says, give me another number. I give it 2. And notice what it did. It printed out the ratio as a float. And it was then able to go to the next line, which says print out OK. And it skipped past the except clause, because there's no error here. And it simply printed, I'm outside the loop. Let's try it again. But this time I'm going to give it an incorrect set of inputs. I give it a number. And I give it a 0. And in this case, I got an error, because trying to take the ratio is going to give me a divide by 0 error. It doesn't say that here because I'm handling the exception. But notice what happened. It didn't print OK because that division of A by B led to an exception. It jumped straight to the except clause, and in this case, it's printed out my error message, which says there's a bug in the user input, and then it goes to the statement outside of the overall loop and prints out outside. The difference here is, if I didn't have an exception, it would have printed out a divide by 0 error. Now I'm actually going to be able to control what do I do when I see an exception. But you can also see it stops the operation, jumps to the except clause, deals with that, and then goes outside the loop. All right, with that in mind, I can now amplify this. Let's take the same kind of example, but now say, gee, there could be different kinds of errors. Maybe I want to do something different in each case. So, for example, if I type in something that was a string, it's not going to be able to do the division because it can't divide strings by numbers. That raises a value error. It's an exception. And in that case, I could print out something useful saying, all right, in that case, I didn't have a number. I want to think about that differently. If I gave it, as I did in my example, a division by 0 problem, it will print out something more informative there, telling me what went on when I had that happen. And in the final case, if neither of these exceptions come up, but some other exception does, I'll still have a default case that I'll use to handle that exception. I could run the same code. I'm not going to do it here, but I could run the same code and you would see the same kind of behavior. If the code runs properly, it will never get to any of these cases. But if I hit an exception, if it's one that I know how to handle, like a value error, I'll deal with it. A division by 0 error, I'll deal with it. Otherwise, I'll go and deal with the overall general idea. What else might I have when I want to deal with exceptions? Well, 2 other pieces. One is, there may be some code that I want to do even if it runs without any exceptions. And so I can put in the keyword else, followed by a body of code, and that will be executed when the execution of the try body works correctly. This lets me pull things outside of the try body. I could leave them in there if I wanted, but it lets me pull things outside of the try body to isolate them as being things I always want to do if it runs correctly. And finally, I can have the finally keyword. And this identifies a body of code with the following property. This is always executed after try, else, and except clauses, even if they raise another error or they execute a break, a continue, or a return. And this is handy when I want to clean up some code, no matter what happened in the earlier code. Typically, this would be something like closing a file so that I don't leave it hanging open. But it lets me specify sets of things I will do independent of what happens in the try loop, whether it runs correctly, it hits an exception and deals with an else or an except clause, or even if it breaks out of that execution and carries on. So there are the pieces of dealing with exceptions. And we're going to look at some examples of using it to actually think about how to handle code using ways to deal with exceptions in manners that we want and not just throwing an error as Python currently does.